Hi friends, welcome to my channel. Let's have a look at the newly appeared problem. Problem 2429, minimize exclusive OR. So in this video, we are going to share a solution based on bit position check and set. So first, I'll read through the statement to digest the requirement, and then we are going to analyze the problem, and finally we share the code. First, let's look at the statement. So given two positive integers, num1 and num2, we would like to find an integer x such that x has the same number of set bits as num2, and the value of x exclusive OR with num1 is minimized. So we are going to return the integer x. So here it also defines what's the set bit. So with that said, let's look at the two examples. In example 1, so we have two numbers, 3 and 5. Their binary representations are given here. So because num2 has two set bits, so we are going to set 2 bits in x. So we are going to set the bits corresponding to the bits of num1. So in this example, num1 has exactly 2 bits. So the x will be 0, 0, 1, 1 in binary representation. So x equals 3 in this example. In example 2, so we get num1 is 1 and num2 is 12. So these are the binary representations. So we are going to set 2 bits. So we are going to set this bit to be 1, and then we are going to set this bit to be 1. So we are going to have 1, 1, that is 3 again in this example. So before we look at the details of analysis, so let's look at the constraint. So the two numbers given are in the range 1 and 10 to the power 9. So this gives us in particular an upper bound for the two numbers. So with that said, let's look at the analysis. So here we're going to use the cancellation property of exclusive OR. So for bit position, if the two numbers in this bit position have both 1s, so then if we do exclusive OR, this bit position will be 0. So with that noticed, actually the idea for this problem is sort of greedy. So we are going to minimize, so our goal is to minimize num1 and exclusive OR with x, given num1 as the number bit we want to set to be 1 in x. What we're going to do is to try to have bit 1 in x corresponding to the bit 1 positions of num1 from most significant to less significant. If the bit 1 positions are exhausted, then we're going to set remaining bit 1s in x corresponding to the bit 0 positions in num1 from least significant to more significant. So that's the whole idea in solving this problem. So next we are going to specify the idea into a procedure. So we actually consider the following 3 steps. First, we are going to get the numbers n and m of 1 bits in binary representation of num1 and num2 respectively. For example, 3 has representation binary representation 1, 1. So here I'm using string just to distinguish. This is decimal, this is binary. So this case n equals 2 because we have two 1 bits. So similarly 5 we have 101, so m equals 2. So this basically says that x will have m1 bits in its binary representation. So this is step 1. So step 2 is to check if m less than or equal to n. In other words, m is no larger than n. In this case, we're going to set m1 bits in x corresponding to the m most significant bit 1 positions of num1. So for example, if we have num1 is 1, 0, 1, 1, and we want to set 2 1 bits, then we're going to set this corresponding to this 1 bit and this 1 bit, that is 1, 0, 1, 0. So in this case, x equals 10. So this is the case m is no less than no larger than m. So if m is larger than m, so we're going to set the first n 1 bits in x corresponding to the m bits bit 1 positions of num1. Then there are still m minus n bit 1 positions to be set in x. So we're going to set this m minus n bit 1 positions from least to most significant 0 positions in num1. For example, if we have num1 is given by 1, 0, 0, 0, 1, so we have two 1-bit positions. If we want to set 4 1-bit positions in x, so we first set 2 bit 1 positions corresponding to the 1 positions in num1, that is 1, 0, 0, 0, 1. Then we want to set another 2-bit positions, that is 4 minus 2, that is 2. So we're going to set these 2 0 positions to be 1. So we're going to get 1, 0, 1, 1, 1. So in this case, x corresponds to 23 in decimal representation. So this procedure actually is what we are going to implement. So with that said, let's look at the code. Actually, the code is rather straightforward. So here, let me write some details so that we can translate the procedure into code format. So first, I'm going to get the binary representation of nums1 and nums2. So for this, actually, we can use a for loop to implement from scratch, or we can use some built-in function in Python. So here, I'm going to use a letter to save some lines of code. So num1 binary and num2 binary. So we're going to call binary function. So num1. So here we are only include the 0 and 1s, not the 0 b in the return of bin of nums1, right? So and then we're going to call this for num2. So also we're going to ignore the first two characters in the return string. So this is the case. So now we're going to count the number of bits in num1 and num2. So number of 1 bits. So this is going to be num1 binary. So count. So we're going to count the 1. So similarly, num2 binary count 1. Right. So this is the case. So then what we're going to do is following the two steps in 2 and 3, right? So we consider the case m less or equal than n. So this is a very simple case. So in this case, I'm going to first make a string. So because here the numbers is bounded above by 10 to the power 9. Actually, if you compute the logarithm with base 2 of this number, it's bounded by 30, right? So actually we can use 32 just to make it sufficient. So first I'm going to do this for character in num1 binary. So here I'm writing in a very detailed fashion. So actually we do not need such long code. So here this is the length of the aux. Then I want to make to pack it to be length 32. So here I'm going to use 0 times 32 minus this length, then plus this one. We can calculate this together. And then we're going to consider the case for m no larger than m. So in this case, so if m is less than or equal to m, so first I'm going to make a temporary variable. So corresponding to x, we want to set some of the bits to be 1 in the temp, and then we compute the decimal representation of x. So first, I want to make a variable called bit set to be 0. So we need to set m bit of 1s, right, in this temp. So for this, let's iterate. So for I in range, because here I want to set from the most significant to less significant. So we're going to do this from index 0 up to index 31. So if the auxiliary I equals 1, then we are going to set temp I to be 1. So here I'm going to set temp to be an integer array, right? So set to be integer 1. and then we're going to increment the bit set by 1, right? So after this operation, so we're going to check if bits set. So if we have already set the desired bit, that is M, then we're going to get the corresponding X from the temp array or list. So this is actually easy. So for answer to be 0, and then we're going to iterate for J in range. So let's iterate from the reverse, 31, -1 to 1. Then answer plus is nothing but temp J times 2 to the power 31 minus J, right? So this is actually very routine. So we're going to return answer. So this is the one case. So another case is the else condition. So if M is larger than N, we need to set all the N positions corresponding to that of num1, and also we need to set some 0 position to be 1, right? In this case, so we need to set M minus N ones from right to left. In other words, from least significant to most significant. So these positions will correspond to the 0 positions in nums1. So this is actually also easy. So bits set, so originally it's 0. And then actually we can work directly on the aux list, right? We don't need to use temp anymore. So in this case, so we're going to iterate for I in range 31, -1, -1, and then we're going to check if aux I. So in this case, notice that aux I is storing strings or characters. So if it's 0, then we're going to set aux I to be 1, right? And then what we're going to do is bits set increment by 1. Then we're going to check as in the last case, in this here, right? So if bits set equals M minus N, in this case we have M is larger than N, right? So then we're going to get the decimal representation of the number. So then we're going to iterate for J in range 31 and -1, -1, and we're going to answer increment. So we're going to change this aux J to be integer, right? So then we're going to compute the powers, 2 to the power 31 minus J, and then we're going to return an answer. So this actually deals with the case M strictly larger than N. So the reason we do it with the aux, because we need to keep all the ones in the aux to be 1, and then we need to change some 0 positions to be 1 from right to left. So this is very convenient if we use aux itself. So this is a format of solution to this problem. So let's first do some special case check. Yeah, it passes the example 1, I guess. So now let's look at example 2. Yeah, it passes example 2. Now let's look at the generic case. Yeah, it passes all the cases. So here, actually, in this video, we give a very detailed analysis and very detailed implementation for this idea. So actually, this solution for sure can be simplified or optimized. So with that said, I guess that's about it for this video. Thank you.